When you think about skyscraper, how exactly do you define one? You probably think about height, number of floor, or just that feeling of looking up at something tall, which is pretty reasonable way to look at it. However, like many technical terms, the word skyscraper did not have a single official definition in the 19th century. Its meaning evolved over time. According to the Council on Vertical Urbanism, the term emerged in the early 1880s from the perception of exceptional height, from seeing buildings that were considerably higher than most others around them. But of course, what counted as exceptional height in the 1880s looks very different to us today. Several newspapers from that era helps clarify this. One of them, the Chicago Daily in 1883, mentioned what New York called skyscraper at that time. Buildings described as a 12-story building or having 8-story flats, and include the list of buildings considered skyscraper at the time. The earliest example of that list was the Equitable Building, completed in 1870, followed by several other New York buildings. As second source, the Real Estate Building Journal reprinted a list of Chicago's skyscraper, originally published by the Daily News. Looking at the two lists side by side, New York seems to have had skyscrapers before Chicago. Yet, when we search for the first skyscraper today, Google points to the Home Insurance Building in Chicago. At first glance, this seems puzzling. It was neither the tallest building on this list nor the earliest one to be completed. So, what made the Home Insurance Building different? What was so special about the way it was built to call it the world's first skyscraper? To understand how skyscraper appeared in Chicago, we first need to understand the story of the city itself. Just think about it. In 1830, only a few hundred people lived there. By 1885, the year the first skyscraper was built, the population had grown to nearly 700,000. In little more than half a century, Chicago transformed from a small frontier settlement into one of the largest and fastest growing cities in the world. How did the remote settlement grow faster than almost any city on Earth? Firstly, Chicago's rise was rooted in geography. Long before American settlers arrived, Native Americans used the Chicago area as a key portage connecting the Great Lakes and the Mississippi River system, making it an important route for travel, migration, and trade. After Fort Dearborn was established in 1803, Chicago emerged as a major commercial and transportation hub. The fort was the first step toward military control of the region. The city was officially incorporated as a town in 1833 by the state legislature. Two developments turned Chicago into the transportation center of the Midwest. First, the Illinois and Michigan Canal, completed in 1848, connected the Great Lakes to the Mississippi River system. The prospect of the canal alone triggered a speculative land boom years before construction was finished, as investors bet on Chicago's future. Second came the railroads. In 1850, only one railroad entered the city, the Galena and Chicago Union. 6 years later, 10 major rail lines converged there, linking Chicago with the east, south, and west. The completion of the Transcontinental Railroad in 1869 reinforced Chicago's position at the center of a growing national network. That infrastructure produced industry. Grain and livestock arrived from across the Midwest to be traded, processed, and shipped around the world. Lumber from Wisconsin and Michigan poured into Chicago's riverfront yards, making the city one of the largest lumber distribution centers on Earth. The same timber supplied the inexpensive building material that fueled Chicago's rapid expansion. Another significant industrial development was the establishment of the Union Stockyard, a meat processing complex so large it operated almost like a city within a city. Opened in 1865, it quickly transformed Chicago into the livestock and meatpacking capital of the world. At its peak, the yards received 3 million cattle and 6 million hogs. From the Civil War through the 1920s, Chicago processed more meat than any other city on the planet. That industrial machine needed workers, and workers needed somewhere to live. Between 1865 and 1900, 14 million immigrants arrived in the United States, drawn by factory wages and the promise of something better than what they'd left. Many landed in Chicago. Germans came first and in the greatest numbers, nearly a third of all foreign-born residents by 1900. Many Irish immigrants came to Chicago in the 1830s to work as laborers on the Illinois and Michigan Canal. After the Irish potato famine began in 1846, thousands more arrived to work on railroads. By 1900, nearly 80% of Chicago's residents were either foreign-born or the children of immigrants. Wave after wave, each one needing housing, fast and cheap. What went up was the balloon frame. Contemporary observers joked that the technique made house building as easy as blowing up a balloon. This building method, common from the 1830s onward, used vertical wall studs running continuously from the foundation to the roof. You could put a two-story wooden cottage in days. Developers did exactly that, packing wooden cottages tightly together across a flat landscape with almost no natural drainage. The trouble is that this building approach building up risk. The wooden cottages were packed so tightly that a single fire could jump from roof to roof without touching the ground. The streets were too narrow for any kind of containment. The building standards, where they existed at all, were routinely ignored. Chicago had built itself into a trap, and in October of 1871, the trap closed. By 1871, Chicago had become one of the most important commercial centers in the United States. Yet, the city's rapid growth had come at a cost. Nearly 90% of its buildings were constructed of wood, including houses, warehouses, railway facilities, and stockyard structures. Even commercial buildings in the downtown area relied on masonry walls for structural support, while their internal structural systems consisted largely of timber columns and wooden floors. On the evening of October 8, 1871, a small fire broke out in a barn on DeKalb Street. Winds quickly spread the flame through densely packed wooden neighborhoods. Within an hour, the fire crossed streets and advanced toward the city's commercial center. By the morning of October 10th, approximately 17,000 buildings were gone, and one-third of city's residents lost their homes. The fire had burned a corridor roughly 1 kilometer wide and 8 kilometers long through the city's center and north side. City authorities moved quickly. Within months, new fire codes were written. The new regulations primarily focused on limiting combustible materials within the city fire district. Balloon frame construction was prohibited in the central business district, and exterior walls were required to be constructed from brick, stone, iron, or other non-combustible materials. New rules helped reshape downtown Chicago, and the people who could afford to invest were the ones with capital. That capital arrived quickly. The port and the rail network had survived intact. The infrastructure that made Chicago a freight hub was mostly south and west of the burn zone. Materials for rebuilding could be ordered and delivered within weeks. Commercial rebuildings began almost before the ruins had cooled. But if wood is off the table and brick has physical limits, and the ground won't support the weight that stone required, then what exactly is building supposed to be made of? To answer that question, we have to go back about 30 years before the fire to a problem that engineers in Britain were already dealing with. It started with a bridge. In 1779, an iron founder named Abraham Darby built a small arch bridge over the River Severn in Coalbrookdale, England. At the time, it was first cast iron bridge built after nearly 2,000 years of masonry bridge construction. Once people saw that it worked, they couldn't stop thinking about what else iron might do. During the 19th century, iron appeared in bridges, warehouses, markets, railway buildings, exhibition halls, and eventually commercial architecture. Thomas Telford's Menai Suspension Bridge of 1826 showed how iron could suspend a roadway from above rather than support it from below. Later in the century, that logic crossed the Atlantic and reached one of its great expression in the Brooklyn Bridge. But bridges were only part of the story. The more important architectural breakthrough came when iron entered the building itself. In 1851, Joseph Paxton's Crystal Palace in London demonstrated the power of prefabricated iron and glass construction. While it was not designed as a high-rise structure, it challenged the traditional dependence of masonry walls as the primary structural system. Around the same time in New York, James Bagardis was developing cast iron building systems. By the late 1840s, he had begun constructing commercial buildings that used iron columns and framing members to reduce reliance on traditional load-bearing walls. His system, patented in 1850, represented an important step towards the later development of skeleton construction. Bagardis' most important contribution came with the McCallum Shot Tower of 1855. In this structure, A self-supporting iron frame carried the loads while masonry panels enclosed the exterior. By the time Chicago architects began building upward, iron construction already had a long international history in Britain, in France, and New York. Chicago was therefore not inventing iron construction from scratch. The challenge facing architects was different. The Great Chicago Fire of 1871, followed by the Boston Fire of 1872, exposed the limitations of contemporary iron construction. Also, cast iron itself did not burn. Exposed iron members could deform, crack, or fail when subjected to extreme temperature and rapid cooling. These disasters challenged the assumption that iron alone could provide a truly fireproofing building system and forced architects and engineers to reconsider how metal could be safely incorporated into buildings. The turning point came after another major Chicago fire in July 1874. Unlike the earlier disasters, the consequences were felt by the insurance industry. The National Board of Underwriters said it would stop providing fire insurance to the city unless the city improved fire safety and building practices. Among the proposed reforms was the prohibition of cast iron columns, which many insurers consider unreliable when exposed to intense heat. The crisis didn't end the development of metal construction. Instead, it redirected. Architect Peter White responded by developing one of the first practical fireproofing systems for iron columns. His early experiments led to the use of protective covering and, later, hollow terracotta units. These innovations allowed architects to retain the structural advantage of iron while satisfying growing demands for fire resistance. Rather than abandoning iron, architects entered a transitional period of hybrid construction, combined protected iron members with traditional masonry walls. This transitional approach can be seen in buildings such as the First Plater Building and the Montauk Building in Chicago. At the same time, several other technological developments were converging. Elisha Otis' safety elevator had made upper floors commercially viable. Hydraulic elevators improved vertical transportation, while steam-powered cranes and hoisting equipment simplified the assembly of heavy structural elements. George Brown Post took the next major step with the New York Produce Exchange. Completed in 1884, that building consisted of a vast, column-free trading hall at ground level, surrounded by 4 stories of offices arranged around a central light court. To span the trading hall, Post designed long-span wrought iron trusses supported by large cast iron columns. Post used cantilever brackets to move the truss support away from the columns, creating clear-story windows that brought natural daylight into the hall. Around the light court, he exposed a multi-story iron framework of columns and beams, filling the spaces with brick panels or large windows. Post's innovative use of iron trusses and framing demonstrated the potential of metal structural system, laying the foundation for the development of modern skyscrapers. These experiments were soon continued in Chicago by John Root, who adopted Post's concept of organizing large commercial buildings around the central light courts in such buildings as the Insurance Exchange, the Phoenix Building, and later the Rockery. John Root was one of the leading architects who helped shape the architectural movement that would later become known as the Chicago School. Despite the name, it was not a formal movement. Rather, it was a group of architects and engineers who were confronting the same practical problems: how to build higher, admit more daylight, improve fire safety, and maximize valuable urban land. Many Chicago school buildings experimented with iron and steel framing, large plate glass windows, and new approaches to structural design. Among the leading architects of the Chicago School were William LeBaron Jenney, John Root, Daniel Burnham, Louis Sullivan, Dentmar Edler, and the firm of Halliburton and Roche. I don't want to focus too much on the Chicago School or discuss every significant building because I think this topic deserves a separate video. However, I'd like to briefly look at 2 more buildings from that period that, in my opinion, played a key role in the transition toward the modern skyscraper. First of them, the Auditorium Building by Dentmar Edler and Louis Sullivan. Completed in 1889 as a mixed-use complex of theater, offices, and hotel, it used load-bearing exterior wall reinforced by a steel frame to handle the concentrated loads above the theater's columns-free interior. Edler engineered the foundation using a pyramid distribution system, spreading weight across a wider base to compensate for Chicago's soft ground. Another example is the Monadnock building, completed in 1891. Boredom designed it without a steel frame, using load-bearing masonry walls that reached 16 stories. The walls at the base had to be nearly 2 meters thick to carry that weight. It was the last serious attempt to push masonry construction to its absolute limit, and it showed exactly why that limit existed. Within this environment, one building would eventually acquire a special place in architectural history: William LeBaron Janney Home Insurance Building. Today, the Home Insurance Building is widely described as a world-first skyscraper. The label appears in architectural websites and has become one of the most widely repeated narratives. The Home Insurance Building was not the first tall office building and not the first structure to employ iron framing, nor was it the first building to use elevators. Earlier architects, including James Bogartis in New York, had already experimented with metal structural system, while George B. Post's New York Produce Exchange demonstrated how iron framing could reduce the structural role of masonry. Many of the technologies associated with skyscraper therefore existed before Janney began work on the Home Insurance Building. Even the building itself was transitional rather than fully modern. Completed in 1885, the Home Insurance Building employed a hybrid structural system in which metal columns and beams carried part of the load, while masonry piers and walls continued to play an important structural role. The exterior was not yet a true curtain wall. The metal frame did not completely replace traditional load-bearing masonry construction. For this reason, some people have questioned whether the Home Insurance Building should be considered the first true skyscraper. If a skyscraper is defined as a building supported entirely by an independent metal skeleton, then later buildings may present a stronger claim. Yet, despite these objections, the Home Insurance Building continued to occupy a unique position. Its importance comes not from being the first to use every skyscraper technology, but from bringing several existing innovations together in one building.